Okay, hi everyone. It's Mr. Morrissey. Today our objective is to solve absolute value in linear equations, and also we're going to be using the point slope standard form and slope intercept form to write equations of a couple lines. Y equals x is a sort of a, I don't want to say easier equation, but I think of that as my upward sloping line that goes through the origin, which is 0, 0. And just to be sure, just if you were going to use a chart or a table, I should say, you plug in 0, you get 0. You plug in 1 for x, you get 1. And you plug in -1, you get -1. The intercepts are both 0. It's going to get harder, don't worry. B, this is a special case that the SAT people love. Horizontal. Who knows who these SAT people actually are? But horizontal, that's a horizontal line at y equals b. Who knows what b is, except that it's positive. So this is y equals b. And the slope, this is something that's good to know, the slope is 0. And we will practice that a lot in our problem sets. So this point right here is 0, comma, b. Remember, you can pause at any time. We're going to go to, let's see, part C. Make sure this is still recording. Okay, we're going to go to part C. So this is a horizontal line. Oops. So this is a horizontal line, and it says A is less than 0. So really that's just trying to tell us that we're in the second and third quadrants. And I'm actually interested to know what you think. Should this be A or negative A? I'm going to say A since A is already given to be negative. So whatever A is, it's a negative number. And coincidentally, so the slope here is undefined. So the horizontal line and the vertical line are the two special cases, and they're good to know. And then here's D. So this is an equation of a line in mx plus b. That's the slope intercept. And the b is the y-intercept. So that's y-intercept. And the m is like a mountain. Shan, that's a mountain in Chinese. Shan. But people actually say that M might be for mountain, or in Spanish, montaña, and in French it's like something. Don't know what it is, but that, so you can think of it as a mountain. Okay, so mountain. These hills are alive. So here the slope is 1 and the y-intercept is -1. So -1, and we're going to go up 1 over 1 and down 1 over 1. And here's a rough sketch. And this is 0, comma 1 and 0, comma -1 because we were asked to graph the intercepts. Okay, so that's D. Let's go to E. So I'm going to scroll down here. So E, the slope is -1. Okay, we have a friend that I like to talk about called the invisible 1. And here, I guess it's an invisible -1. But a lot of people might think that the slope is x or the slope is 0, but there's actually an invisible 1 there. So it really is y equals -1x minus 1. So the invisible 1 is something that's going to come up a lot. And the y-intercept's -1. The invisible 1 means we have a negative slope, up 1 over 1. So this is going to be -1, comma 0 and 0, comma -1. Let's just make sure that -1, comma 0 works, because I really, sometimes I say in class I don't like negative numbers. So let's see. This is going to be 1 minus 1. That's 0, and that's what we were trying to get. We were trying to show that the y-coordinate would be 0. All right. Remember, you can pause, you can rewind at any time. But we'll keep going. Here's f. So f is absolute value. we know that a normal absolute value graph, I usually use a different color. Here's the normal absolute value graph, y equals absolute value of x. And with the negative in front of it, that's just going to be a flip. So we're actually going to have a negatively sloped line, or the upside down v, and the y-intercept and the x-intercept are 0, 0. Done. Now we can try a harder, what do you call it, absolute value. So this is going to be sort of like a vertex form. The shift is going to shift over, let me see, to the left 1 unit and down 2 units. So the first thing you should do is plot the v, the vertex point. So you're going to go over 1, down 1, 2. And since there's a negative in front of, or you know what, I shouldn't do that. I'm going to highlight it. Anytime anyone has a good suggestion on how to like make these videos better, I'm all ears. So like here, this negative, what that does is mean you're going to have an upside down v. So let's see. The slope is going to be 1, so I'm going to go down 1 over 1, down 1 over 1. And let's see if this makes sense. So here's what I'm saying the answer is, and this would appear to be 0, negative 3. And you're like, oh, Mr. Morrissey, that doesn't seem to make sense because, okay, I'm about to highlight what people are going to think. Oh, they're like, oh, negative 2, that's got to be the y-intercept. Well, that's not right because look, the y-intercept, I always will say y-intercept is f of 0. I haven't started with function notation, so maybe I shouldn't do that. But if I say y equals negative 0 plus 1 minus 2, negative 1 minus 2, the absolute value of 1 is 1. Well, this is negative 3, so there you go. Negative 3 is the y-intercept. My graph's right. And don't fall into the trap of thinking that just because this negative 2 is the last number, that it's the y-intercept. Okay, we're looking good now. So those are some graphs. Now let's go to 2. Find the coordinates of the midpoint. Let's see how we're doing on time. All right, 7 minutes. So let's find the coordinates of the midpoint. So, what am I trying to do? Okay, here, midpoint. So x midpoint is x1 plus x2 divided by 2. Just add the coordinates together. So let's see. I'm going to add the x's together, and I'm going to add the y's together. Nine, 15 over 2. So the midpoint is, the midpoint is 9, 15 over 2. Sort of an ugly number, but I'm pretty confident that's right. And then for the distance formula, to find the distance between the 2 points, so let's see. We'll start with the negative numbers to make this a little harder. So the difference between 3 and 15 is 12. Negative 12 squared is 144. Difference between 3 and 12 is 9. So 15 is the distance, distance between the 2 points. Okay, find the slope of, decimals. Who likes decimals? I don't. So let's see, 1/4. We have our 2 points. So, okay, let's see. So there's my setup, 3 over 2 minus 1, 1/4 minus a half. How am I going to do this? Let's see. So 1/2 over, so now dividing by 1/4 is the same as multiplying by 4/1. So that little dot here, that means multiplication. God, that's a long word. So times -4. So it looks like the slope is -2. All right, we got 2 more left. So let's see. Show that the line through 2, 3, 5, -2. Well, let's find the slope. So the slope is -5/3. Show that the line through those 2 points is perpendicular to 3x minus 5y equals 15. So this is standard form, which we're going to get to in the next question. And standard form is ax plus by equals c. A is greater than 0, and a, b, and c are all integers. Okay, so let's find the slope of 3x minus 5y equals 15. So it would seem like 3/5 is the slope. And so if 2 lines are perpendicular to each other, then the 2 lines are negative reciprocals, their slopes are. So slope 1, the little dot means multiplication, times slope 2 has to be -1. So is 5/3 negative times 3/5 positive? Well, that equals -1. So you've shown that the 2 lines are perpendicular because the 2 slopes, they're not the same. They just multiply to -1. You might have done that in geometry. I bet you have. Okay, we're almost done. We're going to power through this, go to number 5, and we will be done. All right, so you guys have hung in there. Now, this is my first video of making all year, so I need to work in my repertoire of, jokes, observations, things like that. It's actually a really nice day right now. Anyway, so I'm going to get to the last one. I hope everyone's having a great day or night. And remember to fill out the video summarizer if you're in my class. But anyway, here we go. So write an equation of a line with x-intercept -3. All right, immediately we have a point, and y-intercept -5. So you immediately have a second point. So let's find the slope. So -5/3 is going to be the slope of this line. And look, you already have the y-intercept. So someone asked me today, like, when do you use certain lines, certain equations of the line? Well, when are you going to use the y equals mx plus b form? The mx plus b form is good if you know the slope and you know the y-intercept. Well, this problem tells you the y-intercept. So we did one simple calculation for the slope, and now we have point slope. No, is that not something? Slope intercept. These names, they all sort of blend together, right? But you have to think about it. You have the slope, intercept, you have the intercept, and you have the slope. So intercept refers to the y-intercept. Now, let's change that. Well, actually, let's do point slope form, which apparently is Miss Irving's favorite. Point slope. So point slope is a good one. So in point slope, you only have to fill in the things I just underlined. So you can take any point. So there's an infinite number of possibilities. So I'm going to choose, let's choose -3, 0. So -5/3 was the slope, and we have x plus 3 since it was -3. There's point slope, done. You don't have to simplify. You can just leave it like that. People have a tendency to want to like change it back to the slope intercept form. You don't have to do that. Now to get to standard form, I think coming from points slope intercept form is the easiest. I'm going to start here, and I'm going to say multiply everything by 3. And then move the x to the other side. We said by definition, you want to have a to be positive. So it looks like, wait, let me rewrite this because it's a little messy. 5x plus 3y equals negative 15. Okay, so 5, 3, and negative 15 are all integers. The x is coming first. The x is positive, so we're good to go. So the 3 answers, I'm going to highlight them right now, okay? Yellow. Here is slope-intercept form, sometimes called y equals mx plus b form. Here's an example of point-slope form with the point negative 3 comma 0. And then here, let's get rid of that. There is the center form. All right? So hopefully this was relatively painless. I hope you enjoyed my first video. Um, Sometimes it might not be me. Ooh, 16 minutes. I gotta go. Okay. Bye-bye.